And the mana previous Peter. Review freedom and Piraba. Yesterday we have completed your formula number 26 and now we have to start your 27. Before starting this question number 27, let me express one more formula for your VRMS. VRMS kita we have discussed how do we obtain your first expression rho over 3p by rho. We discussed the record. And what was the second? Rho over 3RT divided by molecular weight MW. We discussed in the very beginning. But ek hoga kana discuss the way ba. Nangi formula you will find this VRMS is equal to kya manaba. We have this is root over 3p divided by rho and root over kya manaba 3 RT divided by this is MW molecular weight, and the third one will be 3 KT divided by this will be A minus Ibra. So we have discussed how do we obtain this, how do we obtain this. This is the most important, by the most important one is this middle one. Middle one check up chipapo and hagi ko. Next up we pressure relation discuss the last we have to discuss your root over 3 KT divided by mass M. Now what was the conclusion of our kinetic theory of KTZ? KTZ kinetic theory of gases and for this kinetic theory of gases, what was the final mathematical result? Mathematical result to P is equal to 1 by 3 into this is capital M into this is B R M S square and we have discussed in your question number 26 natra 26 now very simple we have considered total number of molecules to total number of molecules to be capital N mass of one molecules na M so that the entire mass M is equal to M into N. This was the formula. Total mass the total mass will be capital M is equal to mass of one molecule here this is 1 by 3rd into M into N. Can we write like this? Here this is multiplied with V R M S. Capital V denote the entire volume of this container. Capital V denote volume VRMS. Small v will denote the RMS velocity in a high degree. And PV can be written as PORT. Then we have this one, PV is equal to mu RT. This is the direct consequence of our kinetic theory of gases. From our kinetic theory of gases, we have your pressure volume. The multiplication or the product of pressure and the volume will be exactly equal to 1 by 3rd of the total mass multiplied with the speed with which every gas molecule is assumed to move. Nangi magi gas molecule khudi makse magi velocity kya da chale han lo ino sa V R M S na move to it chale lekhan manatro we assume that every gas molecule is moving with this speed V R M S the chale having yatra yareko provided that this is the temperature and from your ideal gas equation pressure will be equal to number of mole multiplied with your gas constant into T since now this equation is from your kinetic theory of gases and from our ideal gas equation PV is equal to mu RT, so we replace PV equal to mu RT replace the understand the now I simple one if we consider 1 mole, so the mu is equal to 1 mole then what would be the total number of gas molecule inside this container? If we take if we consider 1 mole of any gas is the 1 mole then what would be the total number of gas molecule masing kya hogi? The total number of molecule will be exactly equal to nangi Avogadro number ko mana kadra mana roito. Because we understand that in 1 mole of any substance it will contain how many number? It will contain 6.022 into 10 to power 23, which is also known as Avogadro number. Avogadro number yaw ni habra. So the number of molecule in this 1 mole of gas molecule will be equal to kya manani n becomes kya manani na ibe habra. Let us see the change in the equation by equation do tingi ngasi number of mole de kya no 1 into this is r into this is t na ibe habra yare ko. And this is 1 by third amat thambiro. And what is the mass? This small m represent the mass of 1 molecule niko se. Small m na mass of 1 molecule ni. And what is the total number of molecule in 1 mole? That is Na. M into this is Na into this is BRMS square. Now sida yung see Na is now when transferred over here, this will become R divided by Na, and this 3 become multiplier over here, and this is T. Can we have this one? Sikhangi ko. So M into this is BRMS square. Therefore, this is exactly equal to kaigamane. I mean R sida kanani yelaba. If the universal gas constant is divided by Avogadro number, then there will be a new constant. That new constant will be known as K. Say, the Boltzmann's constant K na hybrid. Siki maming say the Boltzmann MANN constant. Yagata. Hangani ko ay is kamaro ko. Here this will be K na eta 3 kT divided by mass m transfer over here, and this is equal to BRMS square. Why do I na sikang high that you by have this high kasi I solution give I can sum up by just telling the formula you by have this in terms of mass and height. But CE step said this step would be repeatedly used in your upcoming topics. So hundreds and use to guriya ba aduna siya tumu thuktai yaradra. Simple the kamai harani. What is the most important formula that you have to by heart for our VRMS? The velocity with which every gas molecule will be moving inside this container, maintain at temperature T will be equal to 3 RT divided by MW. MW will be the molecular weight. And what about this small m? See small m, this small m denotes the mass of 1 molecule. Understand the way? Yaradra. I has a basic parameters ki meanings dikhamo. P stand for the pressure, rho stand for the density layer, T is the temperature of the gas, MW na molecular weight, R is the gas constant, K stand for the Boltzmann's constant layer, T stand for the temperature, M stand for the mass of a molecule. Finish. There I go. Simakhange. Ado itaradi angtang hayam get question nama I ngarang skip to giwam dai noi na tum hosa gadaba. You have to do it by yourself. Question number 85 sa ito gidaba mali ngarang. Ito gibra tawg de ko. Question number 85. Yo. 85 tawg de. Ay nataw hay gibra no da. Question number 85 sida mana pili sa kay pira. For your question number 85. The root mean square speed of hydrogen molecule of an ideal gas kept in a gas chamber at 0 degrees Celsius. 0 degrees Celsius ID temperature is equal to 0 degrees Celsius and this will be equal to 273 Kelvin. Kelvin next, what is the VRMS? VRMS our VRMS is given as 3180. Now pressure is equal to we have to calculate this. And what about density? Density is 8.99 into 10 to the power minus 2 mapibra. And from here, from this given data, we have to calculate the pressure. Question understand though, I interpret even though listen carefully, this is very important. Even though VRMS can have an expression in terms of your pressure and density, pressure ka density ka yoga my formula lejabata ragusune. VRMS is independent of pressure, the independent oil, density the independent oil. You increase the density or you decrease the pressure, it doesn't matter. Okay, it doesn't matter. Your VRMS will not be changed even though you change the density or you change the pressure. Nang pressure hongera, density hongera, nangi gas molecule ki speed to hongoiba, VRMS to hongoiba. Khangani ko. Adugu, if you change the two parameters, two very important parameters. What are the two very important parameters? Number one will be the temperature. Number second will be the molecular weight. Khangani ko. Your when VRMS is directly proportional to temperature. If we increase the temperature, or in simpler language, if we heat up this gas molecule, see gas molecule is there, heat supply to Rekalazeva, the gas molecule will be moving with a faster speed. Speed increase the in so. Yabra, temperature increase the when a body will increase the temperature, the body will increase temperature only when heat is supplied to the system. Heat low amount of increase the Adunani, very simple logic. Let me give you a day-to-day life visible of example. If you cannot open the lid of the container, you simply heat it up from the bottom. Morning the mic open why? Your VRMS increases. Due to the supplied heat, your temperature inside the container will increase, and the increase in temperature will consequently increase the momentum. Momentum increase to force will be increased. If force is increased, the pressure inside the container will be increased, and the pressure will be in the upward direction, and that upward direction, that upward acting pressure will easily overcome the lid. Lid to makundo man open to nga makra na may hangi ko yung simple logic ta, simple meaning the temperature increase, then the gas molecule will be moving with a faster speed. That's all. Yara understand the ko. This is the most important. Even though we have expression in terms of pressure ka, the density the your VRMS or the speed of the gas molecule will depend only on two parameters, that is the temperature and the molecular weight. Heavier is the gas, slower will be the VRMS. Now the hydrogen ka oxygen ka compared to the hydrogen is lighter at the same temperature hydrogen will be moving faster, will be moving at a faster speed, whereas oxygen will be moving relatively slow. Anyway, now let us come to our C formula. C hypothetically VRMS square will be equal to, this is 3P divided by rho. Can we have this expression? Yeah, bro. Do you understand this one? Our VRMS in terms of pressure and the density will be root over 3P by rho. If we have to find out the pressure, then we have to take this out of the square root. We have to take this square root. Therefore, our this will be P pressure P will be equal to VRMS square into rho divided by 3 plus 1. Then we have this one. VRMS की value क्या no? This is 3180 into this is 3180 into what is the density? Density will be 8.99 into this is 10 to the power minus 2 divided by this is 3 divided by here you can approximately take this 8.99 to be 9. See, this is only 0.1 difference. Then exam the calculation simple you assume this 8.99 to be 9. This is almost 3 you calculate the remaining at your home, and this will be exactly equal to Pascal. Understand what is the standard unit of pressure? Pressure is standard unit Pascal. magi question the option the kari pi atmosphere na pi bra. In your option it will be given in terms of atmosphere banina. Very simple sida yo 1 atmosphere is equal to kya ga mana ba 1.01 into 10 to power 5 Pascal ka mana bro mana da bro mana le adu ita is simple oina. The answer that you obtain after this multiplication must be divided by 1.01 and it will be converted into atmosphere converter already. Do you understand this one or not? Nang divide to kasi kailangan divide to butare. Sida na very simple way na na. Nang gisda nang napangiba answer to. You will get a product ang family dra. That product must be divided by 1.01 into 10 to power 5 and it will be now converted into atmosphere converter already. Finish. Yara tra. Yara ko yan siya. Complete this at your home. Complete to sir. Aduga we will start your formula number 27 degree of freedom is very important niko. Degree of freedom ne asibu you can skip this degree of freedom jo skip to way for concept point of view this is very important but you should remember formula number nangi 29 and 29 is important hoite formula number 30 is very important from physics point of view this is important ore ado nang chemistry da ju yam important oi sidala ise am the degree of freedom like for your question number formula number 27 you have to understand what is degree of freedom. So let us consider any gas molecule. In our reality we have three dimensions. One would be x, y, z. So this gas molecule is permitted to move in three directions. X it can move in the x direction, y direction or z direction. I understand bro. So any gas molecule can have three possible motion, direction of the motion. It may be either in your x-axis, y-axis, z-axis. Every possible way, direction, every possible path will be known as degree of freedom. All the gas molecules are free to move in x direction, y direction or z direction. Okay, so the possible direction or the possible path that can be taken or that can be chosen by your molecule set. Degree of freedom correct. And how to calculate your degree of freedom set? You remember only this very important 3 n minus r. See formula remember and forget the remaining concept. Just formula how to remember the degree of freedom. Degree of freedom can be easily calculated by using this relation. F is equal to 3n minus r, where n is known as number of atomicity, number of molecule, number of atoms present in a molecule. Atomicity in understand to ngami aduga r sine kay do sa this is nagi chemistry lo da dhana number of bond ay hayo r is equal to number of bond aduga in our physics study independent relation hayo. Understand to ngambra yare ko. Now let us consider for monoatomic ki halaw si say monoatomic ki the what would be the atomicity n is equal to 1 tamang nopra. Yan tayo ko ay harise. Monoatomic gas samadati it will be number of atom present will be only 1 and is there any bond formation? Bond formation am talay gada na. Alay roy. There will be no bond formation so it will be kya tarani F equal to 3 to 1 minus 0. So it will be 3. Yan ka. Degree of freedom for your monoatomic gas will be equal to 3 matare. Next number 2 daw yung nasi for diatomic molecule na di kaya nani sa for diatomic molecule example na magpiro example na di nangi H2 hydrogen abra lagi nangi O2 hydrogen abra N2 hydrogen abra we have nangi how many how many atoms atom mani lebra and it will be represented by this. This is your atom number 1 this is one hydrogen and this is one hydrogen, and we have a bond in between these two atoms, and your R is equal to 1. Number of independent relation is equal to 1. Here very simple our F will be equal to 3 into what is the number of atom? Number of atom is 2 minus what is the bond formation between these two atom? 1 Libra 1. Degree of freedom will be 5. If you can by heart the exact value, then you don't have to memorize your formula. If you do not, if you cannot memorize your exact value to the 30, at least you try to understand this formula and apply the basic concept. We apply the way now. Now let us consider for your number 3. Number 3 the triatomic. Triatomic molecule amtang hairose hairenge nangi carbon dioxide su kaya triatomic oibra adi NO2 su kaya triatomic oibra oire ko by etc mayam legre ai chemistry hite I just know only these two si kitang or mina kamani ibetare karam mongde lege number A, the possible number in the linear or this is money we have nang carbon dioxide kamai ke smai create the rana a linear or all the three atoms are aligned along a straight line am the plug thamra a straight line then it linear ka way yatra yareko adu that here if we represent in a what physics point of view the this is first, this is second, this is third. First atom, second atom, third atom, they are connected. One in the first atom and the second atom is connected by relation number 1. Second atom and the third atom is connected by relation number 2. So total number of independent relation R will be equal to 2 tare. Therefore our degree of freedom will be 3 into what is the total number of atom? 1, 2, 3. Total number of atom minus what is the number of bond that is available in this linear configuration. 1, 2 Libra minus 2, and this will be equal to 7. Understand the record? Next time number be the non-linear level example of the high bring it. Smiley water is the water is not a gas nothing. For simple understanding is the water water is not a gas put in the for your better understanding water is a shape oxygen is diagram triangle shape just like that we have the three atoms aligned along the direction of a triangle side represent this is your R1 and this is your R2 and this is your R3 this is 1, this is 2, this is 3. That means for triatomic, okay, for triatomic molecule we are going to have two different types of degree of freedom. If the triatomic molecule is linear in nature, what will be the degree of freedom? The degree of freedom will be equal to 7 and what will be the degree of freedom if the molecule are if the atoms are arranged in a triangular manner of the arranged our degree of freedom will be exactly equal to 3 into 3 minus what is the total number of bond 1, 2, 3. It will be 6 understand the simple logic you take like this. For monoatomic 3 or diatomic it is 5 or triatomic it is 7. Common winner. We consider the odd multiple from odd number from 3 that start over 3, 5, 7. This is how you should memorize the exact number. Yeah, and come we go. Nana Sigi formula if you do not remember this formula, you simply consider or you develop a shortcut trick develop the our degree of freedom start from odd number 3. Next odd number will be 5. Next odd number will be kya tagani 7 naman tayo na. Pero simple oy na our gas molecule the simplest or basic kay oy monoatomic hangani ko. Next diatomic, next triatomic amla pra. For monoatomic it is 3, for diatomic it is 5, for triatomic it is 7 in general case. Yara tra? Understand to ba? Nauri ko. Simple way. Yare ko. Now mathang dam lai sam kay lai sa. After having this concept clear, see concept clear where khalaga. Next man formula number kya dale me 28 amal libra. 28 se talking and you underline this is very important. Nang na formula number D da at high temperature abra. Sidale ise ai na develop to reason je. All the degree of freedom which I have already written over the board set, it will be for low temperature or it will be for your room temperature na low tan. Yara ni ko aduna tabida heat of sumata your degree of freedom will be changed and kogi usually kanana kogi nature da majority of the it is in the form of diatomic gassing there. You have to remember for the majority below at high temperature your diatomic molecules will have how many degree of freedom? At high temperature a diatomic molecule will have 7 degree of freedom. 5 is already at the low temperature. 5 is already and extra 2 carry that extra or that additional 2 degree of freedom will be due to the vibration mode. High temperature in addition to every degree of freedom we have 2 additional vibration mode happening. Vibration Hangani aduna mana please there will be 3 translatory legani, there will be 2 rotatory motion legani, and there will be an additional vibration to the apiramo and additional apiramo. 2 vibration motions it is due to aroma apiramo 2 vibrations 2 vibrations this is due to high temperature no maram horagane at koi ngasai si 5 hai se sinamti mo 5 hai se 3 will be translatory plus 2 will be rotatory under low temperature. Under low temperature your degree of freedom for diatomic will be 5 and this 5 degree of freedom out of this 5 degree of freedom 3 will be translatory means the molecule will be moving in a straight line. Rotatory means it will be magi rotatory has the circular motion of perform to the yaranga has it come up to go nang se kana mong umbe simple ka hai rotation or circular motion it can be performed only in 2 ways, clockwise anti-clockwise. Tabra ai has it no yam lu da sibo lu de da translatory motion ki di kai no sidle se ai na in detail no tang da gi to budi ko sidle se no diatomic ko it will have amagi 2 different two different atom lakini. This is atom number 1, this is atom number 2. Baba this is combined to ba yare ko see this combined to form this is diatomic hangani ko it can move along the x-axis degree of freedom number 1. It can move together. See together when it's at the ba ai dangi asagi bone number form to na partner they have to move together yai ko along the x-axis, that is straight line fast translatory motion. Along the y-axis they move together, this is the second translatory motion, and third they can move in the x-axis. This is the 3. Along x fast translatory, along y second translatory, along z this is third translatory. Next for rotatory motion it may be clockwise. See clockwise yare ko fast rotatory, anti-clockwise together that is second rotatory. this is how we calculate our degree of freedom for diatomic molecule under normal condition. Under normal condition or at low temperature, diatomic molecule will have 5 degree of freedom, and this 5 degree of freedom is the combination of 3 translatory plus 2 rotational. Whereas at high temperature we will have another 2 additional degree of freedom in the form of vibratory motion. Finish all together. At high temperature your diatomic molecule will have 7 degree of freedom, 3 na kayogani translatory, 2 rotatory, another 2 vibration. Understand the record? See, we will be using this exact exact degree of freedom. We will take this translatory diatomic translatory. This is 3. You have to memorize this. A degree of freedom for your this is translatory. Diatomic or 4 rotatory. It will be 2. Yeah, I had this question. There will be one question. In that question, they will ask to compare kinetic energy for diatomic molecule that is possessed by translatory orientation and another possessed by rotatory orientation. Yagadra? Has it come over the bro? At the minor Hankaneva, Aduna, you have to keep in mind these 3 different compositions. At high temperature, 3 translatory, 2 rotational, another 2 due to vibration. Okay, see next time we see. Right. Oh, similar number T explain the next law of equipartition. Simple in a lower case, young kind of explain the Nangi degree of freedom say every degree of freedom will possess half kg possessed over there. Every degree of freedom have the body, if a body moves along x axis, what would be the energy possessed by it? The energy possessed by the molecule will be half kg over there. Every possible part will have an energy equal to half kT over there. Every degree of freedom will possess half kT, irrespective of translatory, rotational, vibration. It doesn't matter. As Maxwell equipartition laws very simple. Every degree of freedom will have equal energy, and that equal energy is equal to half kT. Every student this is 5 contribution of every student is 5 if there are 3 students studying 5 into 3 15 lakh understand the confusion. So what is the energy associated with 1 degree of freedom? It will be half kT. Very simple. Now let us consider your kinetic energy. So far we have not discussed your kinetic energy. We discussed only your VRMS. VRMS discussed we discussed up to here. A gas molecule will be moving with a velocity equal to root over 3 RT divided by MW, or this will be root over 3 KT divided by M, or this will be equal to root over 3P divided by rho. This was the main expression. Now let us discuss about the kinetic energy. Kinetic energy nangi formula do the khara soibani ko aina override to khara yawi, so nang understand the khalase ko you copy it from here. Sidagi kakhat laga anong point na copy to right hujiki ko ginu ko ana check to ko koina what was the everything comes from your kinetic theory of gases. It will be PV is equal to kya manaba PV is equal to 1 by 3 capital M into this is V R M S square and lakra. CGP is na pressure volume is equal to 1 by 3 into mass. Capital M denote the entire mass natra, entire mass into VRMS square. Sima understand tabu ngami. Now when sida PV is kamaina express tabu yare. PV can be expressed as mu RT ni ibya mu RT, and this is 2 by 3 into this is 1 by 2. 2 get cancel out, and we have m VRMS square ni ibya bro. This will represent your kinetic energy tabra. See kinetic energy tabro. The total kinetic energy of the sample will be equal to half m VRMS. So we will be having sikya manani 3 matabre mose. This is 3 like ko, but 3 into half of my ibiro. This is 3 into this is half into this is mu, this is r, this is t equal to kinetic energy. Can we have this expression? Simple hongre mose kinetic energy is reduced to very simple. PV is equal to mu RT from your ideal gas equation, and how to convert this right hand side in terms of your total kinetic energy. Kinetic energy will be half mv square. We simply put 2 over in the numerator half pe maka 2 ma hapse leko cancel chala hana kidum dong phangmu ngamra ngame. This is the total kinetic energy niko. We are considering this to be the total kinetic energy. Therefore nangi sigi kano sikai la asa sig 3 is kaino. This 3 is the kanang type. This is for your monoatomic tabra. Understood to ngami. Anyway, aina hani very simple oina. Our kinetic energy expression is kinetic energy will be equal to nang 3 jima happy re ko adu into sigi half into. Try to understand this step. Sigi step si khang ngamre mo mu si kamai ni be so kan ti mo sa 3 into half into this is nangi n divided by n. Can we write like this? Fine, use you abra aina nahan hai kare ko. Number of moles say it can be expressed in 2 different ways. The expressed way number of mole will be equal to number of molecule divided by Avogadro number, or in second expression the mass divided by molecular weight, and divide where m stands for the mass of the sample divided by molecular weight. This was discussed in the beginning of our class. It is very simple. We deduce deduce mu say rather deduce mu is deduced to nangi sagi kano se yabre mo ani thona ilage ko si male rasnu sina. This is first step on lage. This is first step number 1, expression number 1 for your kinetic energy, and this will be the second step for your kinetic energy mo ilage. This is RT and ibya bro. This is equal to kinetic energy total. Now adu jantang hairo se sida ji just look over here. Magi equation the p matam da 3 je kari hoy. This 3 is for monoatomic molecule magi tabra, or the 3 can be replaced with your degree of freedom. This is f and ibya bra. This is half and e lage. Next time combine ibya mu hai na mu ibya bra. This is mu into this is r t and ibya bro. Can we write like this? In your formula nang formula sida mo walang meaning. Mag last ibda for mu moles da nang irise kinetic energy is equal to f by 2 into rt. Haraga mu mo what bra? You insert mu mo hapsen mu aina se f by 2 ani idana f by 2 ani ibe mo tana nang simple oina f into degree of freedom into half into mu into rt ani ibe bro yare nang si ju khandre khalajeba. You write like this mu rt into mu half rt. This is very simple oina and set in terms of Boltzmann constant half kT. In terms of gas constant half RT. Yanatra, do you understand the concept or not? Sikhangeko, the kinetic energy will be expressed in two different ways. I expressed the way one in terms of your in terms of universal gas constant expressed the degree of freedom multiplied with half RT, just as in the case of your nangi ngasai kari haba equipartition law na hai half kT na hai dana every degree of freedom will possess half kT, and this half kT is when it converts in terms of your Canada convert over R to convert to half RT na so ibya bra understand the record, and it must be multiplied with your number of moles absolute multiply to running understand the right in short this will be the kinetic energy expression for a collection of gas molecule. Mole even though this is one mole there will be multiple molecules there will be 6.022 into 10 to the power 23 molecules. This formula is to be used for a group of or a collection of molecules may be it may be type nature it may be diatomic or triatomic or monoatomic or we can consider only one monoatomic, we can consider only one triatomic, or we can consider a group of triatomic or a group of diatomic. Consider the diatomic, triatomic, monoatomic will be only for its nature, and here this is for the entire given sample. It may be 100 triatomic, it may be 1000 triatomic. Now let us find out the kinetic energy for only one molecule. One molecule की kinetic energy क्या आता है? This is 3 into this is half into this is divided by R divided by N. This will be KTM tabra. KTM tareko. We will be having N amala kadra. N amala eko. Understand the word me? Simple way na. Kinetic energy क्या आता है? Your kinetic energy will be equal to degree of freedom into this is half KT into this is number of molecules. यार बा यार कोई है से as simple है ना लूना you think it very difficult यार हैंडल खन में मथाउ तादे simple है ना मान के नो से degree of freedom से क्या लेके monoatomic की 1 लेके था 3 लेके ना every monoatomic will every monoatomic gas will possess 3 degree of freedom lebanina 3 into half kT. When the number of one molecule is the one molecule what is the total amount of energy that will be possessed by one molecule. One molecule na possess the kya for x half kT, for another x it will be half kT, for another y z axis half kT. All together kya F into 3k/2 this will be only for one molecule. If there are 7 it must be multiplied with 7 I is a simple is a kinetic energy for one molecule. One molecule for one molecule will be n is equal to 1/2. This is half degree of freedom into this is half kT. Finish. Because every molecule will possess half kT multiplied with degree of freedom. Yarani, aduga mi mangal gorgana n multiply to sidum tarakra. That is general expression. These two will be the general expression for kinetic energy in terms of your multiple molecules or in terms of groups. Sample mole will be related with gas constant. Number will be related with K. R ga mu ga khangani ko R ga mu ga N ga K ga. K ya umham ta yawi simple no ina if it is too difficult for you to understand then you just apply the extend the logic over here. PV is equal to mu RT in hadra. Number of mole comes along with your gas constant galakra. Like what was the third expression? PV is equal to N KT lakra. Like number you taragana Boltzmann constant K galakriba. Mole no oragana kanada lakriba R galakriba. Keep this in mind. Yan tarba. Basena, do you understand what I am trying to conclude here? Hangani ko. Sida R yoragana it comes with mu no multiply to ba. Ado K yoragana it comes with N no multiply to ba. Yare ko. You check the formula to check the chumbralan right there. Yare ko for n number of moles ki di kya tare for n number of molecules ki di half natraga f by 2 n kt. This is direct to me time tak I lete. And for your formula number C, mu is equal to kya manaba kinetic energy is equal to f by 2 RT, and it must be multiplied with kanaga multiply to dino mu mo walidna. You insert mu for your formula number C. Mono one molecule or monoatomic ki we don't have to change to this yare ko. As the simple oina, what is the significance of these two formula? My formula is significance. What is the meaning? This will be used for our calculation point of view, and our physical understanding will be let me write over here. Kinetic energy will be kinetic energy will be half. This is F by 2. It may be K OBI, N OBI, it doesn't matter, K N, and this is TM tabro. Degree of freedom will be fixed for any time. A to fix, K to fix. This is constant. Degree of freedom cannot be changed for a particular type of gas. Monoatomic or 3, diatomic or it will be 5. We cannot change the degree of freedom. So this is constant, this is constant, this is constant. So everything over here will be constant except the temperature lapra. Kinetic energy is directly proportional to our temperature T. What is the main two very important conclusion of our kinetic theory of gas? Kinetic theory of gases, the main conclusion is conclusion number 1, your velocity is directly proportional to root over T, and we know that kinetic energy is equal to half mv square. I have not velocity square of our kinetic energy is velocity square of, you will remove your overlap kinetic energy is directly proportional to temperature T. So far, ma'am, round circular in cell we have to understand only very two important point, that is your velocity is directly proportional to root over of T. Have the temperature T half over the depend and kinetic energy it is directly proportional to temperature T. Now let us do the remaining part of the question. Question number 87 88 ko loina. Next question number 89. Question number 89 da mong tiyo. Say hi kadre ho. Question number 89 I अब तक तो गया तो skip तो okay को. Question number 89 से तमाम अपनी the average kinetic energy of a gas molecule at क्या रमा अपनी से 27 degrees Celsius is 6.21 into 10 to the power 21. Then the kinetic energy at 227 degrees. This is very simple. How to calculate such type of question? Here the comparison is for one single type or one single sample. Sample say the same sample is considered for two different temperature. Do you understand? Man, here is a question. Not the munna power do we have to compare for two different samples? No, not take one serious. Compared to DJ, we compare a given sample under two different temperature, one at 27 degree and another at compared to 227 compared to very simple. Now we can have this kinetic energy is directly proportional to temperature T tabra. Finish. All energy E1 E2 is equal to T1 by T2. And you should not forget to convert your temperature in terms of Kelvin. The convert to where they go. 27 will be 300. Adu T2 ki kya nama piri jai. 227 happy bra. 6 kya tar hai? 273 ka chalo. 500 tabra. This is equal to 500 Kelvin later. And what is the value of your E1? Kinetic energy is given as 6.21 into 10 to the power minus 21 divided by E2, and this would be equal to 300 divided by 500. You calculate simple. If you do not understand or if you do not by heart what is the actual expression for your kinetic energy. Kinetic energy expression is C and Z. Even though you cannot remember this, you should have the very important concept that kinetic energy is directly proportional to temperature. See, comparison with every constant will be cancelled out. Cancel with and we are left with only this calculation done. Yeah, bro. Next up, we have question number 95. 95, so this will be the last question for your kinetic theory of gases. Last question already, and the remaining question will be based on your mixing of gases. This is important. Question important. Why? So for targeting question number question number 95. We have to try to do ko hirani ko. Mana P is 27 degree ka 327 ka P unatra. Kinetic energy will be very simple. You have to find out your E2. Yeah. Sida mana P is temperature T1 se. You have to proceed like this. Same pattern you have to E1 by E2. E1 is then E2 is to be find out. Temperature T1 will be 300. Temperature T2 is kya tarani? 337. Sorry. 327 it would be 600 tabra. Yarani ko. You calculate this 2 times 2 tare. So 2 times tabra mane. Ko. Next time yang asiko. Last time like said this is very important. Nangi heat capacity. Heat capacity yang tang harus saya yang sida silo chendro close taro. Adu tell me what is thermal capacity or heat capacity. In the beginning of our thermodynamics, thermal heat capacity explain the explain the thermal capacity or heat capacity. What do you mean by this thermal capacity or heat capacity? Thermal capacity or heat capacity will be defined as the amount of heat required to increase the temperature or to change the temperature of the body by 1 degree Celsius. The entire body 1 degree Celsius to change to this is body mass m natra. Initially let us consider it is at 30 degree Celsius or it may be it may be 7 degree Celsius. The initial temperature of the body was at 7 degree Celsius. Now we apply heat. Heat applied to heat applied to according to our natural law. If heat is absorbed by the system, temperature has to be increased unless there is change in the state. State change tawdaba taragadi temperature increase tawni. State change tawdadi temperature increase tawbra tawde, which we have already discussed in the case of ice. Ay nang iba sentence gyan tabi ko mayam. Tani ko ay say kari gumba state to si solid web natra. Solid adum oiraga solid adum oiling taragadi ne heat supply tawdadi temperature will be increase. Hangi ko aduga kari gumba state solid or madagi liquid ta change tabi tadi. Even though we supply heat, this supply heat will not increase the temperature. Temperature to ma increase the way. Yai ko hari se khamore ko that heat to na we discuss in our latent heat ki, latent heat of fusion, latent heat of vaporization ko discuss ta ko. And it is simple ina if heat is supplied to the system without changing the state change to the heat supply to and this heat supply can increase the temperature from 7 degree to 8 degree Celsius ta increase to all together kuna dt haigera na traga kana haibase nangi delta t na haise abra da bro this will be equal to 1 degree na ibe ko the heat that is required for increasing the entire body by 1 degree Celsius will be known as company thermal heat capacity na traga heat capacity ko hagibra ai body is 10 degree ai body is 37 level medra ai je fire mu manata ai mai tm fire manata I phame ko I sit just near to a fire manata tham tadi heat will be gained by me I na heat se gain ta binatra so the temperature of my body will be increased from 37 to 38 increase over the amount of heat that is absorbed by me to increase the temperature by 1 degree set it will be known as thermal capacity for my body yarba. So, if the entire body increases by 1 degree Celsius after absorbing some amount of heat, then the absorbed amount of heat will be known as thermal capacity in high graph. And we have this dq will be equal to C delta T. dq is equal to C delta T. This is very important. Number one, the thermal capacity the thermal capacity means it is the amount of heat required for increasing the entire body temperature by 1 degree. Now, what about your small c natraga s specific heat specific heat. What do you understand by this specific heat? Entire body if the entire body is at 7 degrees Celsius, then a particular portion of the body will be also still 7 degree I body 37 or side 37 side 37 side 37 side 37 every part of the body will be at 37 na if we consider for this we consider 1 unit mass ki consider the 1 unit mass the amount of heat required by this 1 unit mass to increase the temperature from 7 degree to 8 degree the increase of high taragadi that is known as specific heat and high dabra entire body that will be termed as heat capacity aduga for one single unit mass of the system the body do see 5 kg let us consider this as 5 kg 5 kg can we write it as 1 into 5 kg the heat that is required by 1 kg is now the heat that is required by 1 kg to increase its temperature from 7 degree to 8 degree that increase to yare 1 unit mass na 1 degree increase to how much of heat is required that will be termed as specific heat. And do you remember the specific heat of water? The specific heat of water will be 1 calorie per gram per degree Celsius and high drop. Fine hagi. That means if we consider 1 gram or if we take 1 gram of water low ko 1 gram of water is taken. See the 1 gram of low. This is 1 gram. 1 gram of H2O at initial temperature there. T1 is equal to 10 degrees Celsius. Then the amount of heat required will be exactly 1 calorie in order to have the final temperature T2 equal to 11 degrees Celsius. Do you understand the basic logic here? There is an increase of 1 degree increase to graph. There is 1 degree increase later, and for this 1 degree increase we require 1 calorie for 1 gram of water. Do you understand? The specific heat height for a unit mass, how much of heat is required for increasing the temperature by 1 degree Celsius. Yaradra, Krishna Kanta Kamo require Harise. Entire body you are thermal space, entire body you are heat capacity. Entire body is one part, not one organ, considered I can consider a vehicle. This is one of the partner. There will be specific heat. Entire body heat capacity, one single unity or it will be specific. Understand the record? What is the relation? C relation heat capacity dQ is equal to C dt C is small c not capital C ni ko. Yarani said now this is K equal to kinetic energy is equal to what was the expression? F divided by 2 into this is R T into this is number of 1 mole. Consider total this is 1 mole. 1 mole if we consider only for 1 mole, then what will be the expression for your kinetic energy? Kinetic energy will be this. Aduga man mining is attempted at Teva. Kinetic energy of the gas molecule is due to the temperature. Kinetic theory of gaseous is after absorbing heat, the temperature will be increased, and this increase in temperature will consequently increase the velocity. Velocity increase means kinetic energy increase. The heat energy is converted into kinetic energy. Heat energy is converted into mechanical energy. Yeah, bro. I say ko, mana sida heat piston do natra. Sida heat piston man the gas molecule in the motion when chalak bro. The motion when the mechanical energy have bro. There is conversion, there is conservation of heat. Heat conservation conservation of energy. Heat energy is converted into kinetic energy. Understand the way? Do you understand what I am trying to say here? Energy is constant. Heat energy is converted into kinetic energy. Finish. Yare ba? Yare. Adu sila ta happy ro. Hey bring siko. Adu ita di sila simple na nangi kinetic energy mo ta can we put it as F by 2 into this is R T ini ibya. Can we have this expression? Your heat given to the system is now converted into kinetic energy of the gas molecules. Yan tayo. Hangi ko. Q value to sila pero here this is dQ mohuta. This is d by dt equal to this is F R T mahapayabra, and this is C into dt. After differentiation we will be having F by 2 into this is R and this is dt. This is dt and this is equal to Sidaju. Lazy, Ganta Udra Dina, smile and Biro. D Mutambiro ko, the Q Mutamage. Can we transfer this Q over this side? dt, smiling Ibabra. Yaiko, this is equal to C. Now, see the lady said. D by differentiation of the heat must be with respect to temperature. This is F by 2, this is R, this is T, this is equal to C in Tabra. And with this dt get cancelled out and we have F by 2 into this is R equal to C in Tabra. Like forget everything. See, don't know we grow. Okay, I can say your CV heat capacity. Heat capacity is equal to F by 2R. Heat capacity is it can be find out under two different conditions. condition anida find out tawbe ba. You are familiar with isobaric condition and volumetric condition khuna tamre ko. Isometric hai taragana volume constant aduga isobaric hai na pressure constant have natra nang cb cv cr cp cp tamidra khuna tapaje cp hai ba matami cv hai tamra tamdabra tamiko gian tawbra ngang se adu itali I will give a simple trick to remember each and every heat capacity for monatomic, diatomic, triatomic because we are going to use this in our mixing of gas. Gas mix the way question hankaneva adu matamda we are going to use this. Darba and go the simple one nang hybrid je nang iside heat capacity je your heat capacity can be carried out under two different conditions. One by keeping the volume constant, another by taking the pressure constant. Am lo ba bra? Yeah. Volume constant of example lang tang hairo. See formula se nang I penalty yaw to ni ko. Formula te E W you remember this sima babu biro heat capacity it may be either nangi constant volume do be constant pressure do be ko heat capacity the relation of heat capacity along with kana ga ba the relation of heat capacity along with our degree of freedom will be like this. Simi abra yani ko nangi formula to na E usi kamai E yawram braba the chamana E is the nangi cb is equal to f by 2r nangi kana PS number 35 te mo PS number 35 to diyaw idna aina takulo brief neba PS number 35 ki relation between degree of freedom and the specific heat aina pibra specific heat sida an bada nangi cb di heat capacity at constant volume is equal to nangi f by 2r ma pibra pi ko sige chamana ta dabra aina mami thonam di wa tane example of nahi hai ko si ko we dekho best example of nangi keno volume constant je si kai hoge dino pressure cooker hai ta volume change ta we abra ya dekho aduna koine any food item se koine cook to matam da pressure cooker ready nangi very fast way bra ai heat jam sang de fast way ai ta di heat jam sang de dana hangi ko less amount of heat is required for cooking inside cooking by using pressure cooker sinda tara di heat less amount of heat ta we can cook the food yai ko adu nangi open oven amada pot ai di hangi ko sa sigi nangi keno le sa phum le khala jeba sigi sa phu sida we have this movable lid ama hap si ko this is movable lid ama hape si burn daure adu itadi boil to matam da nang rice cook to matam da mas overflow to ura to dabra overflow to iko si plate set this plate will be now pathak to karak tabra rice to rai kana khangi ko adu itadi simple example da how this is obtained or how this is explained I do you forget everything you just memorize only the kana concept kana lo khambiro volume constant or na pressure cooker adu ko open na traga kari hai ni se movable lid to or na movable lid ta cook to go or na that will be kari ko ne ba se isobaric process ho jane isobaric process kara madna heat se na more heat will be required in case number 1 or case number 2 sidi common example ida nangi open oven da natraga open pot ta nang na boil to na cook to tadi we require more energy we bra yan ta bai hen je basina hangi ko adu di sida nang heat capacity this is at constant volume will be less and heat capacity at constant pressure will be high more heat will be required under this condition in order to cook the same item. Nangi food to si pressure cooker di 5 minute ta cook to rani si di kya changani 15 minutes changratra 15 minutes ida nang tungna laiya de. You have to apply heat for the next 15 minutes. That means you have to apply additional 10 minutes sigi heat se waste to ura to dabra tawi gyan tai ko aduna most preferably kona low was kai dawi pressure cooker to taragadi energy can be saved. Energy save ai ji no ko gi budget ta economy da save to lina tro sidana more money is going to be waste thagi ko ai je sidana money save to energy save to ura tawi. Which one is favorable? Constant volume isometric process natraga isocoric hai na to chemistry de kai tami isocoric natraga isometric in habra isometric yarni ko ai hedi se the isometric natraga isocoric process the less amount of heat is required than that of constant pressure, that is open bhe hota di kai hen logani isobaric process yarba understand to ngami ko adi nang simple relation da nang ide Cp is greater than Cv na tami ko chemistry da tami here sidu sumeva nang simple concept lo da sina kya darkar ta ne 150 nang joules darkar ta sina kya darkar ta ni it require only 10 joule of heat. Adi this is very beneficial nang gas to si kai do re pressure cooker da sak muta ra it will it can be used for 6 months to use the wear and eba nang pota cook ta di it will be finished after 3 months da finish hoy ga hoy den kana bili asai pressure cooker na kana bhi andra yani koi hai se your Cp is greater than Cv, more heat is required for your constant pressure than that of your constant volume. Therefore, we have this very important relation, Mayer's relation. Cp minus Cv is equal to, or in short, Cp is equal to Cv plus R. This is very important, and this relation is known as Mayer's relation. Mayer's relation. And kana viewer dinu se sida nang khang do se gamma se kai kawi sida haro se Cp divided by Cv se kai kam kawi. This is gamma ko bra ko bra kawi si gamma se kai kawi, and this is known as nangi gas ratio ya ta bro se sida ko we diko capital R se kai no gas constant having ko si ta ko ra ko da confusion na company R stand for your gas constant. Aduga gamma stands for the ratio between heat capacity at constant pressure and constant volume. Adu here we have this very important two relation, Cp equal to Cv. Cp is equal to gamma Cv tabra, and you should remember that Cv is equal to any aside formula do Cv and do Cv is equal to F by 2. Remember this formula. This is the basis of our everything. When we talk about question solve to everything depends upon this. Now I know what will be the heat capacity for is different gas molecules considered. We have monoatomic, diatomic, triatomic. We are going to memorize all these ratios and memorize the goniko. Otherwise, question Cp for monoatomic kya aata hai, Cv for your diatomic kya aata hai. At that time, if you do not know this, it will be very hard for you to solve the question. Yeah, bra? Hey, let's go. Nanti makha question number formula number kya no 21 22 dara nang heat capacity for kana dia ba heat capacity for monoatomic diatomic na idom yaura aldai ido lal hai na te ko aldai ido mana sida kari hani de diatomic hani ibra ma Cv for monoatomic diatomic askradi de ko that is not sufficient. Let me write over here. Cv, that is heat capacity at constant volume will be F by 2R. This is the main formula that you have to keep in your mind. Next, the monoatomic. For monoatomic, monoatomic, your degree of freedom will be equal to 3 manam natra. That is 3. You just put it as 3. So Cv will be equal to 3 by 2R. Finish. Next, the Cp Cp is equal to Cv plus R. You add another this is 5 by 2 R. C by 2R plus R. 3 by 2 is 2 33 plus 2 3 plus 2 5 Next, this is very important. Monoatomic this is equal to Cp divided by Cbm tabra. This is 5 by 3 and it will be 1.67. Even though you forget this, you have to memorize anyway 1.67 because in your isothermal process, adiabatic process, thermodynamics, these are the essential concept that we are going to use in your thermodynamics. Thermodynamics isobaric expansion, isothermal expansion, compression, adiabatic process. Use Next, number 2 diatomic or diatomic molecule. What is the degree of freedom? The degree of freedom to 7 condition that will be under high temperature. In our normal condition, we have to still take it to be 5 in the lower type. So 5 and our Cv will be equal to 5 by 2 R. Next, Cp very simple. Cp will be equal to 7 by 2 R. Therefore, our diatomic ratio will be equal to, this is 7 by 5 and its value will be 1.4 something. Therefore, 1.4 is number 3 simple triatomic in our physics language to the polyatomic polyatomic. Degree of freedom we have 2 different degree of freedom, and you may think that when we consider for the linear, we may get different value for your non-linear game. Case 7 is for your linear, 6 is for your triangular shape. Our heat this is for your linear this is for your non-linear and we have Cv is equal to 7 by 2 R. Cp will be equal to 9 by 2 R. Gamma triatomic will be equal to 9 by 7 and this comes out to be 1.333. Non-linear our Cv will be equal to 6 by 2 R, that is 3R, and Cp will be equal to 3R plus R, it will be 4R. Gamma triatomic this will be 4 by 3 and we will be having 1.33. Irrespective of the nature of your triatomic molecule, we will be still obtaining our gas ratio to be 1.33. So anyhow, monoatomic 1.67, diatomic 1.4, triatomic 1.33. Just by looking at the just by looking at your ratio. Ratio yang kanda kana na khadi chau chawi greatest value le kana gi oge monoatomic na oibra monoatomic na oire sina monoatomic ki oigini ko monoatomic has the highest nangi gas ratio 1.67 mathanda diatomic and mathanda kana ogini triatomic machine number moraga we will have different interpretation yani ko anyway now let's do your question number and also हम कौसी question number 90 ने question number 92 ने 93 ने 94 ने these are very important question ngata ni ko ai hari se noi mark chalo this is the last part of our hit chapter gini koina tamise ai moi ta hai okay so far koina hot river chapter se kari kari bole ahan bata hit ki da temperature bole ko next up how heat is transferred. It is transferred in three different modes: conduction, convection and radiation. And out of these three different ways we consider only the two modes of transfer, that is conduction, radiation. Okay, hey go last last what is the heat, what is the property of gases with respect to heat, that is kinetic theory of gases we discussed right now. And the last part will be mixing of gas, mixing of two gases mixed up. That will be based on your question number 90, 92, 93, 94. This will be the last part. We have already studied 5 different topic niko discussed with the hit da. I will explain the Roy. I will not be explaining this in detail. I will just write the formula from mixing of two gas. I need to mix them regularly. We have the gas type number 1 type number 2 so type number 2 whatever the parameter we do not know it. Okay, so the number of moles na mu1 and temperature T1 and consider and this is temperature T2 mu2 and heat capacity. I am not discussing about the constant volume, constant pressure C1. Let C1 be the symbolic representation of heat capacity for your gas number 1, gas type number 1. This is C2 and how is mixed up and let us consider the total number of gas molecules present in the sample 1B N1 and it has three of them F1 hello. So consider we have your N2 to be the corresponding number and F to be the corresponding degree of freedom. When these two are mixed together, we will be having it's a very simple way. The most common question is what is the heat capacity for the mixer? This is the first formula that you have to remember. Next what would be the temperature of the mixer, and next what would be the gas ratio for that gas ratio to mixture की क्या आता है कि हुआ नहीं ऐसे मोड़ को आई gas नहीं mix तो ना मतलब मान जिसे question can be asked in 3 different ways था हम तो यार first way the mind है कि नहीं heat capacity for the mixer will be how much क्या देखो next what will be the temperature, new temperature after mixing the two gas ini mix or the temperature dia होगी. Next मान सकते हो ना C mixer से it can be either kana will be ऐसा ani तो ये लगे को C mixer at constant volume और से अपना can we have this concept here? क्या को heat capacity of the mixer at constant volume, heat capacity of the mixer at constant pressure. C mixer be at constant pressure. This can be also be gamma mixer gamma mixture se this is very simple hoina C mixture at constant pressure divided by C mixture at constant volume. Yabra Cp by Cv is equal to gamma taidra. Ultimate question je aham da kai hai ai formula idri kano noi ki kano da formula buk yaw dam ni ko you copy this mu1 C1 plus mu2 C2 divided by mu1 plus mu2. This is formula number 1. Temperature T2. Sorry. Sini sindalo ko ay explain taro lagi. Sila isda ini saya ibu formula do soy bani ko mu waragna mu should come along with your r and number must come along with k and the thing yaad na. So let us do your question number and we don't see ase question number 90 je kamai pide question number 90 da question number 90 is the mana pide se wo two monoatomic ideal gases at temperature T1 and T2. Monoatomic hoita d your degree of freedom F1 and F2 will be equal natra. Monoatomic ID it can be rangi kana low example point of view da monoatomic gas ni tang hairo ne helium amle raba argon su ya ba yai ko we consider the mixture of helium and argon low equilibrium. Both are monoatomic or monoatomic will have the same degree of freedom. Degree of freedom सब माना रहे. बाकी इस पिरामिड इसी का ये दो पिरामिड नंबर 2 ने पिबरा we have n1 and n2 to be the respective number of vanina. We are going to use this one. याद आगा? Hey, how we go? For your question number 90, our answer is very simple. Nangi yam line ibare temperature of the mixture will be equal to nangi isda F1 is equal to F2 because the both mixing gas will be monoatomic in nature hota radi your kana hoiba degree of freedom will be equal ore and we can use this one the F si kya ta ge 3 ta na to alum mai irage ko this is equal to nangi F ani isan biro F is equal to this is N1, this is T1 plus mathang da kailani ki amun darka tabra sikki yoroi da ni ko ai force da ta alam ne pakha ki la ko sikki zero pupiro ai sikki ke cancel chana ki do bane ba sidna magi silo rr yawi do bane homla koi bayan ina ka oi koi ju robot na ti computer na ti am ka ji lo ni jang le ta ri ya ro jo al per na zu ka ka ni o ni me le chani ke no yo se si hai ra tra ya ni se Asigi F ka diga na taga this is in terms of N1 the half the temperature of the mixture say can be expressed in terms of nangi kanota number of moles ta expressed to maga in terms of your number ta expressed to me abra yare ko nang si happy ro adu subtract tarani sa this will be equal to very simple hoina f1 t1 plus n2 kanala kani sa n2 t2 divided by this will be f1 common to n1 plus n2 umlaw ko abra. This can cancel out. Otherwise, we have n1 t1 plus n2 t2 divided by n1 plus n2. Finish. Good. Next question number 92. 92 ji are to the suya ani si hairani ko. Question number 92 this is based on your Kanada kinetic energy ki niko. Let me give you a simple hint number piget. If the total number of hydrogen molecule is double that of the oxygen molecule, ade animak se kari ore diatomic आता हो बरा और एको अभी expression common expression for your kinetic energy क्या माने this is F by 2 into this is mu, this is R into T. इसमें लापरा, भाई यूनात्रो, or it can be also be written as F by 2. This is N KT. इसमें ये भी आपरा, we can have this formula that is discussed in your formula number B and formula number D. दा discuss तब देखो C के D के दा discuss तब यूनात्रा B के C के दा बरमान है. In terms of order, this will be F into I think I E like my E. Makara manatana ka E pura ana one uwe standing half this is RT into this is mu. Okay. Al C ki mathan damla isna kamaila hai base we can express this as F into half into this is KT into this is M. This was the formula. The formula ko discuss to bisi na to. Kinetic energy ikami ko. Next, when I know this kind of question number 92 dalay say we have diatomic molecule, hydrogen molecule ka oxygen molecule ka pire. We have to find out the ratio of the kinetic energy of the hydrogen and oxygen at 300 Kelvin. That means temperature is also constant tabra. Tare aduna nagi kinetic energy C tang ase mo diatomic ata waita di oxygen su diatomic ni nagi hydrogen su diatomic na tra. Diatomic it will be F1 equal to F2 is equal to diatomically this is 5 but this term will be constant. This term temperature to temperature of the oxygen is equal to temperature of hydrogen. This term will constant. Here kinetic energy for your oxygen hydrogen na haliko hydrogen that this is ice do ni biya bra mathan the kinetic energy for your oxygen yai ko this is directly proportional to n1 by n2 ni biya bra de ai dikho si number of mole piram deba pera piram ni nagi number of particle massing molecule massing piram idna very simple way now what is the nagi total number of hydrogen ki kya no sma pd se is double that of the oxygen molecule have natra or this will be equal to 2 times NO2 mahapo. You see that this is NO2 only 2 times over ba 2:1 tarbo our answer is 2:1 see not koi ni important hoy hai je ai na sai important hoy na high which in the soil gama mane 92 is not important mixing to niko important or is the this is simply the comparison of kinetic energy. Relatively easy was na. Maestro silo rapat. Basa na loro basa. question number kano da mo yung say question 93 here 93 da lay se asida man yo if 2 gram mole have natra, what do you mean by 2 gram mole? Number of mole will be equal to 2 arnico. So we have your diatomic gas and monatomic gas. Sidale say diatomic amalay re monoatomic amalay bra. Sidang tanging si sen ka hydrogen. Man previous say mu1 second. Let us consider your number of mole for diatomic to be represented by mu1, and this is 2 gram mole hydra. Man previous say 2 mole of diatomic gas is being considered along with 1 mole of monoatomic amapibra. 1 gram mole hydri 1 mole hydri ko. Mu2 is equal to kya log this is 1 and logo yabra. Yari ko. Number of mole for diatomic is 2. Number of mole for your monatomic is 1. This is only given never. What is being asked? Man hangi se kari hangi. You have to find out the heat ratio for the mixer. First, we have to find out the heat capacity for the mixer at constant pressure. Heat capacity of the mixer at constant volume. Find out the that. Adu yang tangi yang sida. Si hybrid si ko hydra hydra. Next time we see say mono diatomic is the what is the degree of freedom? Degree of freedom yaw bra yaw dekho yaw damina hapin dukta pe nagi the C kano hapo se CB क्या आता है C1 VM हारगे सिखंगद्रा आई हाइनिंग इसे हाइनिंग या सिखंगद्रा बसे heat capacity of the gas type number 1 hanganiko at constant volume. Haibidi heat capacity of the diatomic gas at constant volume. Yadra sign CB1 yadra se CB1 haibidi heat capacity of the diatomic gas at constant volume. And this will be equal to kya tani ta hai wo hybrid ke asai ki to the CB is equal to F by 2R. And here, what is the degree of freedom for your diatomic? This is 5 tabra. And here we will be using this is 5 by 2R. The heat capacity for the diatomic gas at constant pressure CP1. This will be equal to 7 by 2R tabra. Finish. Next, gas number 2. Kanano monoatomic ko bra. For monoatomic, your heat capacity of the monoatomic gas at constant volume will be equal to kya manare. This is 3 by 2R tagadra. We have 3 by 2R. And kanao ibitare heat capacity of monoatomic gas at constant pressure, that is CP2, will be equal to kanado manare ni base 5 by 2R lakra. Si mun na khang tai confusion dam sat ni ko adu ine separate hane ire mise akawala si yare kari tab changi sanu ko ai tuan ko lage one single step that we can finish this question in one single step, but I will be doing in separate only call again. Today we C mixer sida kana have a C mixer at constant volume we have to first find out the heat capacity of the mixer at constant volume. Then we will be using C kana manare mu1. What is the value of mu1? So let me put like this. This is mu1. This is C v1. Plus this is mu2, this is Cv2 divided by mu1 plus mu2. You put the respective value. What is the number of mole? mu1 is equal to 2 tabra 2 into what is the heat capacity for diatomic at constant volume 5 by 2R tabra. This is 5 by 2R. plus what is the number of mole for monoatomic 1 into what is the 3 by 2 aram tabra 3 by 2 this is r divided by what is the total number of mole, this is 2 plus 1 and we will be having sigara this is 10 minus ibiroko, this is 10r plus 3r is that 13 13r divided by 2 and this will be 1 by 3rd. Can we have this 1 by 3rd as separate on ibay dana gyan tarbo si 2 cancel simplification do line by no pe one ba 2 into 5 10 tare 1 2 3 tare na 10 plus 3 13 tare 13 by 2 r and for this we will be having 1 by 3rd amlakra separate on hame. Next your heat capacity at constant pressure for the mixer will be equal to mu2 the mu1 Cp1 plus mu2 Cp2 divided by mu1 plus mu2. This is important. You just put the value here, value to option 0. mu1 is 2 mole hapani, Cp1 ni kya mane 7 by 2 r tabra 7 by 2 r 7 by 2 r plus the mu2 की value की 1 and Cp2 की क्या नाम, this is 5 by 2 r tabra, this is 5 by 2 r divided by this is 3 happy ro क्या तारे तो 3 तारे तारा मरी तारा 19 तारे को this is equal to 19 by 19 r divided by 2 into this is 1 by 3rd. Is it visible to the last bench? Asi basina lang umpamra ure ko. Next time yung asi your gamma mixer will be equal to very simple one now. We will be having your Cp mixer divided by kana udino se Cb nangi mixer amalakadra. What is the value? My value is kya 1 by 3 into 13 by 13r divided by 2 and here this is 1 by 3 into 19r divided by 2 amlakadra. This can cancel out, this cancel out, r cancel out 13 by 19 tabra. One single step ka lobe abo question ko adu ko yam confusing set ko isa ida na value put to matam na you have to check it very carefully whether you are putting the correct heat capacity for monoatomic or diatomic se han but that is why I na han ro it ho tha mise separate it tha midra acha ta ro last one final question 94